Hello and welcome to part 2 of the Scratch intro tutorial. In this tutorial we'll be covering the basics of 4-directional movement, so getting our sprite to move using keyboard inputs. So I've just got my game screen up here. I'm going to click on the See Inside button to move into the coding screen, which now has popped up. So what I'm going to do is I'm going to do a little bit of manipulation of my character here, which we named Scratch in the last video, and we are going to get him to move around the screen. First thing I'm going to do is I'm going to set his size a little bit smaller, just so that he doesn't take up too much of the room on the screen. So I'm just going to set the size to 50, hit enter or return. Now, one of the things you can do in Scratch, or is important to know about Scratch, is that your game's screen or dimensions do not change. This is a set locked-in ratio of a number of units, and so it really does not change at all. So if you want to make essentially a bigger level, what you need to do is make everything smaller as opposed to changing the size of the actual level dimensions itself. Everything just gets made smaller, and then you got more room to move around. So I've set the size of my Scratch sprite to 50. And we're going to put in a couple of different things just to help illustrate some of the points I'm making in this video. So moving over here to the bottom right-hand corner in the stage palette, right now you can see I have it's called Backdrop 1, and it is blank white. I'm going to click on the Choose a Backdrop button, just the little blue button. When you mouse over it turns green. Click Choose a Backdrop, and we have a whole series of backdrops here, and they're kind of divided into various categories. I'm going to scroll right down to the bottom, and I'm going to select the backdrop that's called XY-grid. And I'm using this backdrop because it's really useful in helping illustrate how coordinates are used in Scratch and how to get your character moving around. So I'm going to click on XY grid, and you'll see here my backdrop has switched there on my stage, and you can see it here behind Scratch. So we have this grid here, and this is an XY coordinate map. If you've ever used these in math, you'll be familiar with them. The way not all games use the same sort of XY coordinate setup. Some kind of have the Y-axis along the far left-hand side and the X-axis along the bottom, but Scratch uses basically an exact center bisection here of the X and Y coordinates. So if I click on my character here of Scratch, I set my X to 0 and my Y to 0, hit enter, you'll see that he is basically aligned exactly to the center of the screen. So what's happening here is that Scratch is dividing the coordinates of the level into 4 different quadrants. And each quadrant has an X and a Y value. So if I take Scratch and I move him, for instance, up here to this little intersection, you can see there's 100, 100. I'm a little bit off here, so I'm going to just type in 100 there, hit enter. This is positive X 100, so you can see here's the X line, 100 is right there, and on the Y line, the 100 is right there, so he's on X 100, Y 100. Now if I were to change this Y to a negative 100, hit enter, you'd see that he had dropped directly down into, it's still X 100, but now the Y value is negative 100. Change the X to negative 100, and he moves into this bottom left-hand quadrant where the Y value is negative 100 and the X value is negative 100. And then if we change that Y to positive 100, he moves now to this point right here, which is in the top left-hand corner where the Y value is in the positives, but the X value is still in the negatives. So this first quadrant in the top right is positive X, positive Y. This is positive X, negative Y, negative X, negative Y, and negative X, positive Y. So that's helpful to keep in mind as you're kind of plotting in coordinates for how you want your character to move around. You can see right here at the top it also labels sort of the absolute values. So we have from the center 180 Y units positively and 180 Y units negatively, which makes, I believe, 360 total vertical units. And in the X value, we have 240 units from the center to the right and 240 from the center to the left, which makes a total value of 480. So this is a 480 by 360 sized screen, so units of measurement. It's not actually quite pixels, but it's basic units. So let's get this guy moving. Let's move him here to the center line, and let's begin doing a little bit of coding for him. So if you go over here to the code, making sure you clicked on the code tab, all code in Scratch starts with an event. No code will run without essentially an event block starting it off. These are kind of unique within sort of the visual language of Scratch because they have a little hump on the top. So any one of these ones, so this one, this one, this one, this one, and this one, and that one, those all are event blocks that trigger code. The most common one is the first one right here, which is when the go flag is clicked, and then basically it will run the code. So anytime you basically start your game, it'll begin running the code that is attached beneath this one. This is by far the most common event block we'll use. It's used on almost every single one of the blocks of code we're going to do in this tutorial. So I'm going to click and drag it in. I'm just going to zoom in a little bit here. So when the game starts, we want some code to start running, and one of the important things about code is to remember that it runs linearly. So it'll start here at the top, and then it will basically just execute every line of code beneath it until it finishes. There are certain blocks of code that will make it repeat sections, but basic idea is that it will always cycle from the top to the bottom, and then if it has a repeat, it'll go back to that point where it needs to repeat and then go from the top to the bottom again. So what we're going to do here is we are going to get him moving. Now, the way we're going to get him moving is using a couple different blocks in combination. Anytime you want to sense inputs, and so essentially what we want to do here is we want to use a key input in order to generate a reaction, or basically a condition. So we need to basically sense whenever something is being pressed. So I'm going to use my arrow keys as my sensing inputs. Anytime you're working with a sensing input, one really important thing to remember is that you need the game to consistently be checking for those inputs. If it only checks for them once when this thing first runs, then they'll never actually be able to become a sort of a continuous input. And so you need to make sure anytime there's a sensing input that you are always checking for it. And that's what we use a control block for. And we use the control block called forever. So it basically is a forever repeating loop of checking for whatever code is inside it or repeating whatever code is inside it. So we're going to grab this forever block, attach that little tooth there. Notice that a forever block has no bottom tooth. That's because you can't leave a forever loop. Once a forever loop is going, it goes forever. So if you don't want it to run forever, you probably don't want to use a forever block. In this case, we do. So what we're going to do is we are going to create what's called an if statement. I'm going to grab an if-then statement from right below the forever block and just drag it out here. Now this one you'll notice has a tooth at the bottom. You can stack these. You can nest these inside each other. Notice it has this sort of hexagonal polyhedron of some sort right here. There's a number of blocks that kind of follow the shape, so it gives you a clue as to what will fit in right here. This is where we put basically our true-false statement, or whatever we're checking for. So if whatever is here is true, then it will run the code that is inside it. So it's basically like a gate, and if you can get through the gate, it'll execute the code inside it. So what we want to do is we want to check for an input. Checking for inputs happens usually with sensing. So we're basically checking to see if something is happening. Now we have all sorts of different sensing blocks. They're all in this sort of light blue color. What we're looking for is basically a key input. Often these will just have a sort of a default set to them. But if you look here, it says key, and then there's like a drop-down pressed question mark. If you click on that, you can see that there's a whole series of different options that we can use, basically the whole alphabet and numbers. So we're going to check for if the right arrow is pressed. Then we're going to click and drag it. Notice how we get this little white outline. That tells us that it will drop into there. Block automatically resizes, and now we have a little if-then statement. So what this is going to read is, if the right arrow is pressed, then what do we need to do? Now you'll remember we talked about coordinates here, so x values and y values. So y values are our vertical coordinates, x values are our horizontal coordinates. So if we want to move it along a horizontal position, moving to the right, so we want to move him this way, what you will notice if I move him bit by bit this way, taking a look at the x coordinates, you will see that we are moving in a positive direction, right? If I start at 0, 0, and I go up, move it, move it, move it, it will always go up in x value until it kind of hits that maximum of 240. So we want to change the x value to a higher x value in order to move it right. So let's go to our motion blocks and take a look at what kind of options we have here. Now, the most obvious and first option right here is move 10 steps. Now, this is technically correct, but move 10 steps, sometimes you need a little bit of an explanation of what exactly the grammar is meaning here. Move 10 steps for Scratch actually means move 10 units in the direction that that the sprite is pointing. So you can see on our Scratch sprite, direction is 90, and if we click move 10 steps, it'll move 10 units in the 90-degree direction, which does work for us, but I like to be a little bit more precise than that, because this can get confusing as you add sort of other conditions into your movement. So it's better to avoid this for this particular case. What we are going to do, though, is we are going to change our x value. So notice here we have change x by 10 and then set x to 3. Change is relative, set is absolute. So change means take the current value of x and change it by 10, whereas set x says set the x value to a specific absolute coordinate. So we don't want to use set x because that would basically just lock us to whatever coordinate we put in here. So I'm going to grab change x by 10, just kind of the standard, and so now we have a little statement that says if right arrow pressed, then change x by 10. So what we're going to do here is we are going to grab this and we're going to nest it inside this statement right there, and we're going to give it a little test. So it's forever checking if the right arrow is pressed, then change x by 10. Let's give it a little test. We're going to click the green flag. I'm pressing my right arrow, and I will move my character to the right. None of the other arrows work because I have not yet created those inputs. So let's do a very quick and basic repetition of what was happening there. So if I right click here, I can click duplicate, making sure to stack it underneath, not inside. So underneath, if left arrow is pressed. Now remember, moving this way changes your x value positively. So moving the opposite way, you actually have to change your value negatively. So negative 10, right? So you're going to basically remove 10 units from the current x value to remove it the opposite way. Let's give that a little test. Right, left. Here you go. So that's basic right-left movement. Up-down movement is going to be pretty much the exact same thing, but we're going to add one little change here. What we're going to do is we're going to go to our motion, and we're going to add a point in direction block. So we're going to go point in direction 90, which is to the right. That's the default for Scratch. And then point in direction, click in here, negative 90 for left. Now take a look at what happens here. Notice, as I do this, he actually flips upside down. So we need one more block. We need to make sure we're not on a 360 rotation. We need to set our rotation style to left, right. But I'm just going to drop this in before the forever statement. It only needs to be set once unless you change it. So left, right, change it. Now he's walking nicely back and forth, left and right.